Okay, then today we'll do robotics gripper and end effector. So what all things that we'll cover today? Today different types of gripper. Okay, so what we have done so far, we know what is a robot. We know it has to go from a place to another place. Okay, but once it goes to a place, it has to do something, right? So in order to do something, you need to have some sort of end effector. End effector means a gripper is also a type of end effector which can hold something, which can pick a part from a place and it can put it to some other place. Effectively, it can hold something. Okay, it can hold something. Okay, whether it places it or not, that is a different issue. There are many other types of end effector which are there. Okay, other types of end effector include welding welding gun, polishing gun, right? You can have a end effector that can do grinding also, spot welding. So these are all different types of end effector. Gripper is one of them which can just hold an object. So we'll specialize today's talk mostly on grippers. Okay, while doing so, we'll talk about different types of gripper, gripper drives. Okay, what all types of drives that are there, what are different design consideration which has to be taken care of while designing a gripper for a particular application, or rather let us say you have a job in hand, you want to do that job. So what all gripper types, what all factors that will you will consider while selecting a gripper from a given choices of gripper, okay, which are available in the market. Okay, so that is why it makes this very important. Okay, so at least one something that can do some sort of end effector job, that is a gripper will do. Okay, we won't be doing any other type of end effectors in this course. Okay, so robotics gripper. So let us begin down then. Okay. So effectively, as I have told you, gripper is a device that enables the holding of an object to be manipulated. Okay, manipulated, which can be taken from a place or put it to some other place. It is to be picked up or inserted it to other. Okay, or you have to hold something and hammer it something. Okay, so that also is a gripper's job. Okay. So different types of gripper, will first look at different classification, means what goes in classifying given a type of gripper. Okay, in which classification does it belong to, what all actuations, based on the way it operates, based on the actuator does it have, or in based on the primary motion that a gripper jaws can do. So it can be done in various ways. So this is one of them. So we are classifying first using primary motion of the gripper jaws. Okay, primary motion of the gripper jaws. Okay, so what the first one that shows is a parallel gripper. Okay, parallel gripper. In this case, the jaws move in parallel motion in relation to the gripper body. Okay, so yes, there are two fingers that you can see. They will always remain parallel to each other. Okay, and they can go closer and they can go wider. Okay, so that is something that it can do, and it is always in line with this body. Okay, it will always move along this parallel to the body of the gripper itself. Okay, so that is the direction of motion. Okay, these two are direction of motion and they always remain parallel to each other. So that is why it is known as a parallel gripper. This type of gripper is very accurate. Okay, very accurate, because there is hardly any manipulation that it is doing. Okay, they are very accurate, because you are not changing the angle, you are not changing anything. The way it is structured, it is just moved along the direction of internal actuators which are there. Okay, so that is why there is no question of any inaccuracy in these type of things. So what sort of inaccuracy that can happen in any gripper? Any idea? Yes, backlash. Yes, while closing and opening there is a backlash. Okay, yes, that is always there. So that can be taken care of easily by having a spring ended gripper. While moving, at least for opening it uses spring, for closing it uses some sort of actuator, but for opening it uses spring, because while opening you are not going to hold anything most of the time. So yes, you can afford to have that, so that backlash can be eliminated that way. Okay. Other very prominent type of error, inaccuracy which is there, okay, that is found in this type of gripper is it never comes to same distance every time it closes. It is not type of backlash, rather it can be inaccuracy in the actuator that drives it. Okay, so that can be another one. Okay, or there both the fingers are not very parallel. Okay, so in that case what will happen, if you hold something it can fly out. Let us say you are trying to hold the cylinder and your jaws are not like this parallel, rather it is like opened up. Okay, if it is opened up, what will happen, it will similarly, if you press it high, it can fly out. Okay, so that should not happen as well. So more so these are very very simple, and because they are simple, directly driven by the actuator, they are inexpensive too, and this is one of the most widely used type of grippers in industry. You will find this is the one which is there most of the places, because you can design your end of this two fingers, design the fingers in such a way so that it can handle multiple objects. So what all ways you can design it, maybe one of the finger have a wedge sort of thing. Okay, another one also has a wedge. So, and both the fingers can move like this. So what will be the advantage of this type of fingers? What you can do with this? Any idea? Yes, very good. So you can hold something which is cylindrical using two wedges. Okay. So yes, but what happens now? Most of the time, what you would prefer this, a particular size of cylinder will be best fit in this, because that is almost, if you draw a tangent, this wedge shape is exactly a tangent on this cylinder. Okay, so that would be the best fit. Okay, and if you draw a radial outward, it directly is perpendicular to the wedge shape. So that would be the nicest one to have it. Okay, best one to have it, so it can hold it properly. Okay, so this is something that you can definitely would like to have, but if at all there is change in diameter of this is happening, then same finger will not be suitable. So in that case, what you can do, can you do something about it so that you can hold multiple size cylinder? Okay, this at least it has a beauty. Yes, it can handle some sort of variation in the diameter of the object, but yes, whenever it will hold center aligned. It will, final position of the cylinder will not change. What I mean, let us say both the fingers are traveling by similar distance. Finally, wherever they merge together, irrespective of the size of this object, what will happen? Every time the center will be at the same location. Is it not? Do you agree with me? Yes or no? Take a pause and just try to figure out. You have a wedge, you have another wedge. Okay, you want to hold a cylinder, so it will lie here. Okay, when it arrived perfectly in contact with this, okay, it went on like this. Finally it became like this. So center, it didn't shift it. Wherever it was there, it was there. Okay, even if I change the size of this cylinder, it is not going to change. That means a calibrated position, once it is holded, you know where is the axis of that cylinder. is it not? So axis of cylinder is not going to change. That means you can do a planned movement of this particular cylinder which it holds. It won't just hold it, it can do a, you can precisely manipulate it. That means if at all you want this cylinder to be inserted to a hole, you can easily do it. If you know the hole location precisely, you can just align your robot axis and you can insert it. Okay, but there are different other types. In order to take care of multiple sized cylinder, what you can do, or there is another problem associated with 4-point contact. You saw when you are holding a cylinder, you have a contact here, contact here, contact here, contact here. Okay, even a slightest of imperfection in the circular shape of this or in angle of this will cause just 3-point contact. How many points are required to define a circle? A circle is defined by how many number of points? Minimum 3 points. So 3 are there. If at all fourth is there, that is a redundant one, right? If even a slight deviation in its position or shape of this will cause losing of contact in one of them, is it not? So that will be the weakest point where your object can slip, is it not? So 4-point contact is not very good to hold a cylinder, right? Although it has a beauty that holding with 4-point all from equal distance from these, okay, finally it will not change the location of this cylinder, that is fine. But 4-point contact has a probability that one of the contact is not getting established properly and it remains loose. Okay, so in order to tackle that, you have a type of gripper when you have one of the finger has the wedge, other one is just the flat one, and both moves and finally holds a cylindrical object. In this case, how many contacts will be there? How many contacts will be there? 3. Yes, one is here, another one here, another one here, and you can precisely define your finger wedge shape so as to make a proper contacts so that it doesn't fly out. Problem with this is center will shift when you hold this object. Different size of cylinder will have center located at a different location, is it not? So different circular shape, this will be the radius distance, this will come like this. Okay, so this distance will vary, the center line of this cylinder will vary by amount which is equal to radius from the flat finger, is it not? So that is why this changes. Okay, so every time you hold a different cylinder, it is holded at a different location. So it becomes very difficult to precisely insert this. If at all it has to be inserted to a hole, you don't know the axis because radii are changing. Okay, so that is the reason 3-finger has its own advantage. Wedge on one side and flat on the other one, yes, it can hold it firmly because it is circular. If at all you target to hold a circular object, this is the best one because it is making a 3-point contact. But if it is to be moved precisely to some other location, yes, it can cause some error because diameters, this radius can change and axis can also change. So there are different pros and cons. So you now got the idea. So parallel finger can be used to grasp multiple diameter objects, not just diameter objects. You can have a rubber padded, these places can be rubber padded so that you can grasp multiple sized object and it won't slip also. Okay, so there is some inherent advantage of this. It is widely applied, parallel fingers are widely applied. Okay, and you can hold multiple things. So you now got one more idea one more idea that it can hold multiple objects first of all, and yes, please don't make noise. Go off actually. So anyway, so yes, you can at least fit a pad. You can at least fit a pad here, hold multiple sized object. Okay, it doesn't slip off, and it is very easy to work off with. Okay, so these are some of the advantages. So actuation wise, yes, it can run on electrical solenoids or pneumatic pistons. You have seen both of them by now, because you have already seen multiple types of actuators. So you can have electrical solenoids that move these two fingers. Okay, in both the cases you can have natural compliance. What is natural compliance? If it is a pneumatic one, you know, after you hold something, you cannot elevate the pressure. Okay, if at all you have a pressure which is fixed in that line, you cannot apply force more than something, right? So if you can control the force of gripping force by controlling the pressure of the pneumatic line that goes to this. Okay, so they are compliant, they are naturally cushion type, it won't crush something. Okay, 4-bar mechanism, Grasshouse mechanism, I'll show you in the next slide. Twin rack and a piston mechanism, wedge system, these are some of the types of this type of gripper. Okay, so here it goes. So it is a 4-bar mechanism, hope you can understand how it will work, right? So this is one of the gear that rotates. If this rotates, that will also rotate, because there is a gear meshing which is here, and both of them, this is a 4-bar mechanism, right? If one of the arm, if it is a 4-bar mechanism, if one of the arm rotates, this also will rotate, this will move like this, is it not? So that makes it move like this, as well as, because this height will go closer after this distance will, as you move this actuator, it not just goes this direction, it also comes closer. So that is making these two fingers come closer. Okay, so it will move like this. So yes, this type of arm is very simple. It can apply quite good amount of gripping force. Only problem that I see here is, yes, you have a circular surface at both the ends, so that it can grasp something which is cylindrical. If not, then it is rubber padded also, you can hold any diameter object also, it won't slip. But yes, apart from moving the jaws like this, it is also traveling in this direction. That is not always desired. It is very difficult to estimate where you are going to end up. Okay, it has a probability to hit the target, right? If at all it is approached from the top, there is a frame which is here, on which there is an object you want to hold, and your fingers are not just moving like this, rather it is also moving towards the object while closing. So you can hit this object very easily. So that is the problem with this type of things, or you can even hit the table on which it is kept. So this is the problem with this, but yes, sideways it can hold very easily. Okay, and very simple, just one actuator that drives it, and both the fingers, they travel with same amount of distance. Okay, so this is one of them. Another one is a similar one. When you have, I will zoom it further, yes, hope you can see it. So this is a gear which is here. Okay, if this shaft rotates, one of them will move like this, another one will move like this. If it rotates in counter, so actually it is something like this. You have a rack, like this. Okay, and fingers are attached to both of them. Okay, so if this shaft rotates like this, what will happen? Both the fingers will come closer, is it not? Both will come closer. If it rotates in counterclockwise direction, what will happen? It will go farther apart. So that is opening. So this is twin rack and a pinion based arrangement. This is also quite common. This is also a parallel fingered gripper. Okay, what is this? This is a wedge. This is a wedge, right? You can see this. This is a pneumatic cylinder which can push and pull this particular end so that this wedge can travel in this direction. Okay, it can either go in or it can go out, right? So just one actuator and you have two sliding wedges. So once it gets inserted, these two will go apart, is it not? So if you pull it out, what will happen? They will come closer. Okay, so you can do opening and closing. So it is run by spring that brings it closer when this wedge is taken out. Okay, so it is a spring driven from here. Okay, so this is another mechanism also which can do a similar parallel fingered operation. And then there are twin cylinder thing. Okay, so you have a pneumatic cylinder which makes this actuator out in and out, and there is another one also, two cylinders doing this job. But yes, both the travels may be little different. Travel, you cannot guarantee that both of them will travel by same amount of distance. If this will face more resistance, definitely this will travel less. If this faces more resistance, this will travel less. So travel is independent because both the cylinders are different. But in this case or this case, travel is guaranteed that they are going to be same. Okay, so these are four major types of operations of parallel fingered mechanisms. Okay, that is a gripper. Okay, yes. So next one is angular gripper. What is an angular gripper? In this case, what you see, jaws are opened or closed around a central pivot, sweeping or in arcing motion. That means initially the fingers were like this in a closed position. Okay, if at all it opens up, it will open up like in the same point, it will turn up like this. Okay, that is opening. So closing and opening, closing and opening. So you can hold something like this. So while closing, if it sees a bigger size cylinder, it can make this fly off, is it not? So in order to handle that, you have something which is known as enveloping attachment. Okay, you have an attachment which is acting like an enveloping grasp. Okay, so your fingers are moving in a angular fashion, but now you have, it is not just two fingers which are going to move, you also have attachment which is something like this. Okay, so finally you have an attachment on top of two moving fingers, so that if you hold something which is cylindrical or even a square one, it should not slip out while you were closing. Okay, so jaws needs to, so effectively what you see, you have a cylinder, you have a pneumatic cylinder, you can pump in air from here, you can pump in air here, so that this can travel in and out, and effectively that is the one which is moving this, and ultimately you can move this out or in. So this is your pivot, this is your pivot. So this is how it operates. Okay, so yes, this is very popular and widely used. Again, both the fingers will travel similarly, but you need an arrangement like this which makes it quite safe also. Yes, so because it can envelop which is grasped. Okay, even in case of parallel finger, you can have this type of arrangement. Okay, so there are various ways this can operate, but this is very quick because it is not linear motion. When this is moved in a straight line in a linear fashion, the closing is not linear. Linear means it is not proportional. So as it goes closer, it becomes faster. Okay, so this is very faster in operation. Actuation wise, this also can be electrical solenoid, pneumatic pistons, or independent servos. You can have a servo here, you can have a servo here, which independently closes both the fingers, right? So that is an angular gripper. And then you have a toggle gripper. This is a unique type of angular gripper which is toggle position. That means Once it is closed, it cannot be opened up until unless you. So what was wrong in this? If this object applies a force in opposite direction, what will happen? These fingers will open up because there is no locking mechanism. Okay, once it can be open, that means it is back drivable. Fingers are back drivable. So what happens? So while you are in motion, you can have inertial forces arising out of motion. If this object that it is holding is very very heavy, that can apply inertial loads on these fingers, and your finger can be little slackened if not open. Okay, so that was the problem with this. So this is not the problem with this type of gripper, that is a toggle gripper. So in whatever position it is, this also opens and closes in an angular way, but wherever it is, okay, it locks in its position. The pivot point of jaw movement acts like a over-centered toggle lock, over-centered toggle lock. You can imagine if you pull it out, this will further get into this slots. Okay, that provides it in a locking way. So until unless you provide force from this actuator, actuator is like you have a spring to return air to open it up. You apply air pressure, it will open, these will go wider open. Okay, if you just release this air, it will automatically close and it will be in a locked state. It can be electrical, it can be pneumatic. It is not independently servoed one. Okay, it provides a high gripping force. So force by weight ratio of this type of gripper is very very high, widely used again. So why not use the best one? Why should we switch from this to this? So what is the problem with this? Why should we go for this one? What is the problem with this, so that we can switch for this one also? Okay, so there are different pros and cons in each of them. As I have said, in case of parallel mechanism, there are various approaches you can do. This is the best one. You can have a V or a flat, you can have V and a V, you can have semicircular and a semicircular of different sizes. So different different object can be holded. You now know a philosophy of a gripper. Every gripper is unique by its application. By its application. Okay. So that is the reason. Application demands a particular type of gripper. If at all you don't need a locking thing, why should you lock it? First of all, what is wrong in locking something, even if it doesn't demand locking? So there are pros and cons with this also. Okay, so once it is locked, it is locked. Problem is it is not compliant. It is not compliant. You are removing the air and it is closing using a spring pressure. So closing force is always constant. So you have different types of object, so it cannot handle multiple type of object, whereas this can. You can adjust the air pressure and you can have multiple force in order to grip something, and you can all moreover you can attach different type of enclosing in order to envelop something, right? So those things are missing. Yes, based on number of grippers also, based on, this is type number 2, that is based on the gripper type, that is number of fingers. So far you have seen what? Based on the primary motion so of the gripper jaws. So this is number of fingers you can also classify. So this is a 3-fingered one. Each finger can have something like circular shape, or it can have a wedge like this so as to hold multiple point contact, and it can hold a circular object. Okay, so yes, this is a 3-fingered one. It is a self-centering also. That what does it mean? Have you seen a chuck of a lathe? So what is the point in using 3-fingered and a 4-fingered one? Self-centering, because you want it to be self-centered. So same is the beauty of this type of gripper. Every time all the fingers, they travel with the same distance when it moves. Okay, and a cylindrical surface of multiple diameter can be holded properly, and every time it holds different diameter, center will be at the same location, maybe at the axis of this gripper. So you can precisely pick from a place and put it in the another place. Same benefit as we had it in the parallel fingered gripper, which was something like this, is it not? So every time it will hold different diameter, center will remain there. Okay, but yes, you saw there is a problem of 4-point gripping. So this is a 3-point gripping and self-centering also. So yes, this is, but this is very expensive. Number of fingers, they counts to your price also. Okay, that is fine, very good. No, I don't need it now. I'll definitely ask you when required. Okay, so but now I think you have to just keep on following what I am telling first. Okay, definitely I'll ask you. Don't worry. If you have done it, it is very good. Okay, maybe in one of the class you demonstrate after this class what you have done. Okay, maybe tomorrow sometime. Okay, so this is a individually servoed one. Individually servoed one means each of the finger is individually servoed. Okay, so you can adjust, it is more dexterous. That means for a given object, you can have the object location with respect to this wrist at different place. Okay, you can maneuver precisely your object with respect to the wrist also, right? That is not the freedom with this, or with a two-fingered gripper or an angular gripper or any other earlier gripper that we have seen. Okay, so what this can do, it can orient something. Okay, if it is holding something like the way you are holding your pen, you normally hold with 3 fingers, you can precisely move this pen with respect to your wrist, so that you can do small manipulations also. That is what is possible with this type of gripper. Okay, so more finger, better it is, but expensive they are. Okay, so there is a arm hand which is known as biomimic hand. Why biomimic? It mostly resembles to your own arm, your own palm. Okay, so everything is like this, number of fingers are also this, degrees of freedoms are also matching. At the same time, it has tactile sensors over here which can even detect slipping. They are very dexterous. Okay, they can even do further manipulations of small manipulation of something that it can hold. It can rotate something like a tennis ball. If you hold, you can rotate using just your fingers, right? So those maneuverability is there definitely, but they are hugely expensive. So until and unless you need something which requires that thing, you should not go for it. Okay, everything comes at a cost. Okay, and complexity also. Okay, so that is the reason these type of these grippers, they are very application specific, right? So pneumatic finger with a toggle, angular or a parallel, so they can have multiple types of actuators for these also. You can even have toggle arrangement in this also. Even in case of 3 finger, each of them can be a toggle arrangement, right? It can be angular, it can move parallel also. Over here these were moving in parallel. This was additionally helping it to envelop something that it grabs. Okay, so it can even move in an angular way. Electrical servo or rope drives are used. Okay, mostly in case of multiple finger gripper, they are run by ropes. They are not directly, you don't have motor here, motor everywhere. Rather, all the motors are somewhere in its arm, and it drives using a rope that goes to all of them. Okay, that is the normal way these fingers are made, because it is very difficult to attach a actuator, multiple actuator at these locations. Okay, so there are various mechanisms how it works. So normally they have rope drives for biomimic arms, even for this one, but this one is direct driven, okay, using electrical servos. So that is based on number of fingers. There are some other types of gripper which can be classified based on internal or external gripper. You can either hold it from outside, or if at all you have to pick up something, you can hold it from inside also. For example, let us say you have a pressure cooker, right, that has to be picked up. Holding it from the external side, rather, what will happen? Basically, it is very big in size. You have to have a huge opening and closing arrangement. Okay, you can hold it from inside, and more so, external surface of a cooker or pressure cooker is smooth. Okay, it can slip off, but if you hold it from here, so it is better or not, right? Your finger goes from inside and it stretches out, right, the way this is shown. So there is very less probability that it will slip out, rather it is getting locked from inside of it, right? Or this is internal grasping. Okay, part or the geometry, the part itself has a geometry that allows locking, then only this is possible. It can be a 2 or a 3 finger, both are equally good for this. Okay, or an external grasp, okay, which is commonly used. Closing force assists in gripping. Higher is the closing force, higher is the gripping. Okay, but you may require something which is enveloping this. It is known as encompassing. Okay, encompass. Okay, it holds from all around. Okay, yes, and there are many other types of gripper. Okay, one of them, very popular one, is magnetic gripper. You have huge electromagnets here, okay, like a garbage segregator, where you just want a metallic parts, ferrous parts to be picked out from your bin. You can use this type of gripper. These are electromagnets. You have vacuum gripper. This is not just a type of gripper. You have a wide variety of vacuum gripper. Okay, you can have 4 suction cup, 3 suction cup, like a glass surface. If you want to hold a glass, okay, a panel, something like that, then these are very useful. Okay, you can have multiple vacuum suction cup, you can pick it up and you can place it to other place. Okay, these are normally rubber faced. Okay, vacuum can be straight away vacuum, or sometimes they are generated using Bernoulli's principle. What is that? See, you have a venturi like this. Okay, so if you flow in compressed air and vent out from here, okay, you vent it out. This, if you have a hole over here, what this will have? It will try to suck in air from this, is it not? So there is a low pressure which is created here because of high velocity, if you remember. So you can have a gripper cup, suction cup over here. Okay, this is a suction cup. Okay, so you just create a small vacuum using a flowing fluid. This is using compressed air, you are creating a small vacuum. This is also doable. So a compressed air line, you don't need to have a dedicated compressor for that. Rather, you can create vacuum using small vacuum. These vacuums are not very strong, but enough to hold at least small buns, chocolates. This is very widely used in handling food products. Vacuum, okay, very widely used, because they don't do any harm to the object that it is holding. And most of the food products, they are packed in polythene, so it doesn't suck in anything. Okay, and polythene products can be easily picked up from this. So wafers, bread packets, okay, any pickle packet, anything. And there are some specialized gripper. Okay, this is one of them, if you can see this. So multi gripper, tool changers is a different thing that I'll show you. Okay, so what this is actually, This is a Dayal arm, Dayal gripper, a specialized gripper which can take any shape that it comes in contact with. How is it possible? Have you seen a bean bag? You have seen a bean bag? It is just like that. It is just like that. You have beans like a thing inside. Okay. So what you do, press your you press your gripper on top of surface that you want to hold, and then you pull out air from inside. What will happen? The shape of this bean bag will freeze to the shape of object that it is holding. Or sometimes you have iron ferrous particles inside. Okay. And what you do, as soon as it comes in contact with the object, you apply an electromagnetic field to this. Okay. All the ferrous particles will get frozen there, then and there. It becomes like a solid, and it holds something. So you can take the shape of an object, freeze it, and pick it up. So that way you can do hold like this object. You cannot apply a vacuum gripper here, you cannot apply a true fingered gripper. You need to have a multiple type of gripper here. So rather use this type of thing, but they are very expensive too. Okay, you can hold glass, they are compliant also. You can hold fragile objects very easily. Okay, so that is a very special type of gripper. Okay, so yes, you have something which is called a tool changer or a multiple gripper. Instead of having a unique one single type of gripper at the robot end, if your robot has to handle multiple scoops of different sizes and put it to the assembly line, you can have a type of gripper here, you can have a gripper here, and it can rotate. At a time you can use one of them. So you have one gripper, two gripper, three. So based on that, you can, it's like our Devi, no, that you have seen, 10 hands. You can do, एक में तलवार है, एक में ये है. You can have hold multiple things. So same way. It's like goddess, no? So they can hold anything. So it has 4 different types of gripper, and depending on the use, it can rotate and it can hold using one of them. Or you can have something which is known as a tool changer. It is not just a gripper, it is an interface between robot arm, and maybe you have a type of gripper which is here. Okay, you have an interface which is fitted with the robot. Okay, and what this does, this tool changer is can pick up any of the gripper of its kind which is required. So it sees the object, then you take the robot to the type of tool which it needs to handle that kind of object. It picks up that tool, does the job, places the tool back in its place, picks up another tool, does some other job, and again it keeps on doing that. Okay, like the way you can do, sometimes you can hold a hammer, sometimes you can hold a chisel. So you can hold multiple things using your gripper, your hand. Okay, this tool changer does this type of job. So this is not a gripper, this is a tool changer. So you can have an interface that lets you handle multiple type of gripper at its end. Okay, so this is all about gripper so far. Okay, now let us see what all types of drives that can go in. You know very well, I would talk about pneumatic that can hold things in small units, quick assembly because they are very fast, and cycle rate is very fast as well. You can quickly open and close that type of gripper. Okay, easy maintenance because you know there are very less parts which are there, so they are very reliable. So that is the reason they are naturally compliant also. You know, with pneumatics they are naturally compliant, so they are safe for the environment also. So that is the reason this is the one which finds its use to the maximum in the industry. Other very broad category, they use electric motors, they have high accuracy. You hardly need very accurate grippers. Okay, because your object sizes they vary until unless you are handling something like a PCB or a IC chip. Okay, so in those cases you prefer using these. They are very repeatable. Less floor space is required because electric motors they act then and there. They don't need a compressor and an air bottle and those things. They are low cost, easy maintenance as well, but not as easy as this one. Hydraulic, that is required at an extreme case, when you need to handle huge amount of load. You want a huge gripping force to handle something, right? It takes a floor space, large floor space. Mechanical simplicity is there definitely, usually used for heavy payloads. Okay. Others are non-conventional ones are, although they are present, they are hooks. Even hooks are there. They have no nothing like a crane. No, you can just have a hook. You can just have a hook, entangle it, right? You pick it up, place it somewhere. So that is a hook. You can even have a adhesive that just glues it, put it somewhere. But how to unhook that in that case? Okay, you can swipe it out. Okay, you can swipe something on the surface and you can take out, right? Adhesive. Rough surface is also a type of gripper. You can, in order to drag something, if your surface is rough, you can simply drag something, right? You don't have any moving part in this case, right? You want to remove something from the conveyor belt. You don't have to pick it up and place it. You just push it, right? That also is an end effector. You can even have a roller for that reason. Okay, so these are some non-conventional way you can think of. Don't stick your brain to these type of gripper. Somebody must have discovered this. Once you can think non-conventional, you can think something like this, like a bean bag, no? So this is something out of the box you can think. Don't stick to something that is taught in this class or your knowledge only. Okay, yes, just a sec. So yes, there are many other consideration that you should look for while selecting a gripper or selecting a gripper for a particular application, or even when you are designing a gripper. That is quite natural. Yes, you do design a gripper also if at all you need it in order to go a little more inexpensive way of doing something, right? Like in case of our robotics club, students club, they do robotic competitions also. In those cases, they do design their own gripper, not just gripper. SAE BAHA members, they even design the whole of the car to do that competition, right? So same way, they can think of that because they have limited resources, money and everything. So you can always have some your own jugaad sort of thing. Okay, so custom fingers for each application. Now each and every gripper that we have seen so far is very customized for a given application. Even a parallel finger surface of that can have a rubber pad. That also is a type of customization, right? You can have a sticky nature, you can have a slippery thing, you can have a curved shape or a wedge, whatever. So each finger can be customized, right? So now every application you have to customize your finger. Careful consideration on the size, as how much is the travel of your finger. If you know this can travel by 5 mm only, and you have to hold a cylinder which is of regular size of 5 centimeter, so how will you do it? You can attach a finger on top of this, which is normally at a gap of, you can attach something on top of this so that it is, when open, it is about 5.2 centimeter, and when it closes it is less than 5 centimeter, right? So in that case, even with 5 mm opening and closing travel distance of these two fingers, you can hold something as big as 5 centimeter, even larger. You should just need to know how much is the travel of each finger that you can make, is it not? So you should understand the application, size of something that you want to handle, and the gripping force that you desire. Why? Because you know once you pick it up, your robot is going to move. So either you can have an enveloping grasp or a firm grasp so that it doesn't fly off from your finger while the robot is in motion. That is very unsafe, right? So normally we do make wedges, we do make circular holes inside. Okay, in the gripper you make this type of surfaces so that you can hold something which is cylindrical, or maybe you can have a rectangular slot, right, if you want to hold something which is rectangular, right. So that gripping force is very important. Shape and size of the object that you want to handle is also very important. So you have seen you can have an encompassing grasp using V groove, a retention finger, a third finger, which may be a dummy also, You have just two fingers, but you can have a dummy to support from both the sides. If you feel that it can fly off from the other two sides, right? So you can have that dummy arrangement that increases the stability and reduces the necessity of gripping force. Friction force in this surface is also very important, right? You can have sensor whether your gripper has closed. Okay, you have commanded your gripper to close, but whether it has closed or not, you should have a close feedback of that. In order to do that, you have what? You have Hall effect sensor, proximity sensor. Sometimes you have a load cell. If you have gripped something and you have started picking it up, definitely you will see some load changes. Using that load cell also you can come to know, yes, now I am holding something. I am not returning empty handed, right? So tactile sensors are there in order to detect some slip. Magnetic switches are there. Sometimes you have protective covers also. As I have said, you can have protective covers so that your object doesn't fly off once you have hold it, right? So general design practice is there. Okay, what it says, just now I have discussed, so you have to minimize the weight effect on the robot performance, right? Based on that, your finger, your whole of the gripper is part of the payload. Let us say your robot can handle 5 kg of payload and your gripper itself is of 3 kg. So how much load that additional it can carry? 2 kgs only, right? So your gripper itself should be of lighter materials, right? So that material selection is very important. If required, your finger, if it doesn't require too much of strength, you can drill holes on that, right, so as to make it lighter. So that is something which is to be done. Minimize the size, right, which helps minimizing the weight that you have seen just now. Reduces cantilever load. If you can handle something with a small finger, why to hold it with a tongue which is very long, right? So unnecessarily designing a finger which is very long will unnecessarily create cantilever load on these actuators, right? So you have to design this so as to have minimum cantilever effect. Moment of inertia is also increased if you change the length of your gripper fingers, right? But yes, they may conflict with the flexibility. Okay, if you reduce the size, you are less flexible, right? If at all you need some flexibility, come compliance in your design, you may have a longer finger also. Yes, maximize the rigidity. Again, reducing the length will maximize the rigidity of that. Okay, it improves the positional accuracy and repeatability of this finger. Every time it closes, it bees there. Okay, it also reduces any vibration and its after effects, right? Maximize the holding force, reliability to hold. This is very important, but without creating any damage to the object, right? Holding force has to be optimized. It should not be too much also. Orient part to maximize force in the direction of motion, right? this is something which is to be taken care of by the programmer also. Okay, you have to orient this part so as to maximize the force, right? You let us say you have a gripper which is this long, you have to hold an object, so you can prefer it holding here, you can prefer it holding it here every time it holds. Okay, so depending on the size of the object and the situation, you can you can program accordingly so as to have maximum gripping force. So this is the place where with the same amount of torque you can have better force, right? So this is something which is to be noted for an angular gripper. At least if it is angular gripper with the same torque, you see more force which is getting generated here, less force over here, is it not? So you have to orient your part, you have to precisely plan your path so as to hold it properly, and maintenance and form factor changes. So if at all you can handle with parallel finger, why should you handle with the rotary fingers or angular gripper, right? Unnecessary maintenance will come, right? So these are some of the design practices or even selection you have to be very careful. So what we have done for the design, we have to take care while we do the selection of any particular gripper. So you have to do workpiece analysis, object must be handled, what is the weight, process analysis, that means if you have to move with 1 meter per second, it's quite high of a velocity. If you have to move very slow, it is okay, you can hold with minimum amount of force and you can handle that. You have to take care of the dynamic effects of load also. So you have to analyze the process, right? Whether you are picking it from a conveyor, putting it to a basket, it is good. But if you are picking it from a conveyor and it is like a knife, you have to cut something, definitely you have to very careful about its path, your trajectory, your dynamic effects, many other things. Okay, and definitely the design consideration, something that we have learned just now. Okay, finger design should be like a cradle, or it should capture the object, it should be repeatable, right? It is like a gripper, stroke length and all is to be taken consideration. How much is the stroke length? We have just seen with an example while holding a 5 centimeter object just now. Okay, issues like a clean room. If it is a clean room, what is a clean room? What is a clean room, anyone? Clean room is basically a room where you have a limited amount of particles floating in air. If it is a 100 class clean room, that means 100 particles of 1 microns will be floating in 1 meter cube. 1 meter cube of air in at that region. So that is a clean room. It is mostly used for IC fabrication and precise electronics manufacturing thing. Okay, so in those cases you have to be very careful while choosing a gripper. If it is a corrosive environment, it has to be IP certified type of material which should go in. What is the temperature? At that temperature, what whether you can your gripper can withstand. Is there any radiation? If there is any radiation, electronics part they go bad very fast. Okay, so that is the reason. If it is any radiation, if it is there, you have to select a gripper accordingly. Waterproofing if it is required for a painting application and all. What is the air quality, lubricating or non-lubricating one. So these are some of the issues with this gripper that has to be taken care of. Above all is the cost, right? You have to optimize with the cost, flexibility, changeover. That means your assembly line today it is handling a car of some model, tomorrow it is going to handle a scooter of some other model, right? Your assembly line can change, right? But your robot remains the same. So you would always prefer to have even the gripper remains the same, right? So that is the reason you should be very flexible and changeover should be taken care of. Safety, in case of power loss, in case of collision, what will happen? Handling, that means while moving it should not throw off, and there has to be a feedback for sensing and many other things. Okay, so these are some of the things that are to be considered when you think of selecting a gripper or while designing a gripper, right? So finger design, gripper design and its selection. So this is very, very important apart from knowing different types of grippers. Okay, that's all I think. That's all from me. If there is any query, definitely you can get it.